Hi everyone, in this video we're going to go through how to determine transformations. So basically looking at transformations, instead of applying transformations, we're going to determine what transformations have been applied. So I've never actually done a video with a PowerPoint before, so let's hope it all goes smoothly. So basically the aim is to figure out how to determine transformations. So you're given an original function and then the transform functions, and you have to determine what the transformations were. So you can do it through mapping, and sometimes you can just do it from inspection, but that's not always the case. So I'll show you both in this video. Make sure you're also watching the Edrollo videos, and then you've also got the chapter 4 check in Edrollo to do as well. All right, so here we've got in this column applying transformations. So this is basically the steps that we will use to apply transformations. And when you're determining transformations, it's basically the reverse. Okay, so if you read through those steps, you can see they're pretty similar. We're just doing the opposite. So it's kind of when you learnt how to solve equations back probably in year 7, it's like, well, what do we do with x? And we build the equation and then we undo it. So it's kind of like the opposite. All right, so let's have a look at the steps in determining the transformation. So this is what you would do by mapping. Okay, so you can't always determine transformations just by inspection. It's always good if you can, but it's not always going to be possible. So in the first step, in your transformed equation, rename x and y to be x dash and y dash. Okay, so that's our image. So rearrange the equations to be the same underlying structure as each other. Okay, and I'll explain what that means in a sec. Read off x equals and y equals in terms of the dash variables x dash and y dash, and rearrange. And then interpret your transformations. So sometimes having steps is quite difficult, so let's apply it to some questions. We'll come back to inspection in a sec. And I feel like I've done a lot of inspection here, but we might do a question where we don't have inspection. Let's have a look at this question here. All right, so for question 1a, for the graph of y equals x cubed, all right, so that's our original. Find the transformations to get this one here. So y equals 2 times x minus 1 cubed plus 3. So we can easily, when you understand how to do inspections, it's easy to see what the transformations are, but you have to have gone from a basic graph. So we're going from y equals x cubed. If you were going from, say, the graph or the function in part 2 to part 3, you're going from a graph that's already been transformed from x cubed to another one that's been transformed. So you can't just do it from inspection, although sometimes you can. But if it's too complicated to do by inspection, you can do mapping. So that's what we're going to do. And I've just noticed that we don't have much space on this page, so I might actually go and open this in a Word document. All right, so this is just going to be a little bit easier to draw. Okay, so we're doing 1a, part I. So we're going from y equals x cubed to y equals 2 times x minus 1 cubed plus 3. So we'll do it by mapping first, and then I'll show you how to do it by inspection. All right, so in your transformed function, we're just going to change it to y dash equals 2 times x dash minus 1 cubed plus 3. All right, so we can do some transformations here. So basically I just want to get x cubed. So I just want to be left with this part here. All right, the x minus 1 cubed. So I'm going to take away the 3. So y dash minus 3 equals 2 times x dash minus 1 cubed. And then I'm going to divide both sides by 3. And dividing by 2. Dividing by 2 is the same as multiplying by a half. So I'm going to just put a half out the front there. All right, so I now stop there. So when you think about when we were applying transformations, we say, all right, y is equal to a half, y dash minus 3, and then x is equal to x dash minus 1 cubed. All right, so I just now need to transform them. So to get rid of the half, multiply both sides by 2. And then we're left with 2y plus 3 there. And then on the other side, oops, don't need that cubed there. Sorry about that. X equals, oops, sorry, don't need those. All right, starting again. X plus 1 equals x dash. All right, so now we can read our transformation. So we're basically just looking at this part to read our transformations. Okay, so looking at what happened to your x. So let's start here. So we've gone to the right 1 unit. Now I probably should say 1 unit in the positive direction of the x-axis. And then the other one we've got, so try to do your dilations first. So it's been dilated by a factor of 2. From the x-axis. So remember that changes your y values, and then we've gone up 3 units. All right, so these are our 3 transformations. Now, just remember, with transformations, there is more than one way you can get your image, okay? But doing your dilations, then your reflections, and then your transformations is just going to give you a little bit of consistency. So just do DRT, so Dr. T. All right, let's just make that a bit bigger so we can see everything. Now, if I was doing it by inspection, now this was on my PowerPoint. Let me just go back to the PowerPoint. Let's make sure I've got the right one. All right, and let's have a look at your basic. So if we look at the green box, we can see a parabola. All right, it's in turning point form, so that means we can see the transformations. So your value of A is your dilation factor from the x-axis. If it's negative, it's been reflected. H is your translation along the x-axis, and K is your translation along the y-axis. So this squared here, all right, in this case, you could say it's also your cubed. All right, it doesn't actually make any difference because when you have a bit more experience with transformations, you'll see, oh, it's pretty much just the same thing as parabolas, and it applies to cubics, and it applies to other graphs as well. It's just probably a little bit harder to see. So we're working with cubics, so it's not too bad. So let's rewrite our original equation. So y equals 2 times x minus 1 cubed plus 3. Now, the important thing is we are going just from x cubed, okay? So we're not going from a complex graph to another one. So that's why we can do it by inspection. All right, so our value of, if you think about the same thing with your parabola, a value of A is 2. That's our dilation factor from the x-axis. All right, and we did that here. All right, same thing, doing it by inspection. We can call it H. Usually we don't use it H, but let's just call it H for this one. H is equal to 1. So that's positive H. It means it's gone to the right 1 unit. All right, so there it is. And then lastly, we've got K is equal to 3. And that means it's positive, so we've gone up 3 units. So you can see we did mapping, but inspection, if it is in the right form, is so much easier to do, all right, by inspection. So mapping is a skill you need to have, all right, because it'll work every time. Inspection won't work every time. All right, so maybe we'll do another question. So I might have to rub this out just so we can make some space. Obviously, you can just rewind the video to get those notes. I'm sure there's an easier way to rub this out, and probably would have been good to pause the video so you didn't have to watch me rubbing it out, but anyway. All right, so let's do one more. All right, so, and then we'll get back to the PowerPoint. All right, so let's do one from C. All right, so this time we're going from a cubed root graph. All right, and it's a basic one. All right, there's nothing that's happened to that. It's just your basic cubed root graph. And we're going to y equals cubed root of x plus 3 plus 2. All right, so remember, I'm following the steps in the PowerPoint. So if I go back to the PowerPoint, when I say the steps, these ones on the right-hand side. Okay, so you can rewrite them in your own language because maybe what I've written there might not make sense, and annotate your example. So perhaps for this one or the previous one, just annotate it. Say what you're doing each time. All right, so our very first step is we're going to just change y to y dash, and then we've got the cubed root of x dash plus 3 plus 2. All right, so we're just putting a little dash here to say that's our image. Then I need to rearrange it. So I'm just going to take that 2 away from both sides. All right, and then we stop there. So basically, you just want to be left with, if you were thinking of substituting something in for x just here, all right, that's what goes in. So everything around it needs to go over to the y side. So like we did in that previous example, we took everything away. We took that 2 and the 3 away. So we're just left with, if I just go up here, just left with this part here, what we're cubing. Here we're just left with what's happening to our x. I did notice I've got to put the dash on there. Okay. So y is equal to y dash minus 2. So just need to rearrange that. So y dash is equal to y plus 2. And then on your right-hand side, what is happening to our x's? So x is equal to x dash plus 3. And then x dash is equal to x minus 3. So just what has happened here and what has happened here. Now, obviously, this one easy to do by inspection. I shouldn't keep saying easy. I mean easy in terms in relation to mapping. All right, inspection is so much easier compared to mapping, but mapping will work every time. So maybe we'll have a look at a question where you have to use mapping. All right, so what's happening to your x? We're going to the left 3 units. And to your y, we're going up 2 units. All right, no dilations or reflections or anything happening here. Now, when we look at so that's your answer. When we look at our function, what's actually happening here, remember with the parabola, when you have what's inside the bracket, the x minus h. So think of the 3 here, or you can see if we rewrote that as x equals negative 3, all right, our h is negative 3. So that's why we've gone to the left 3 units. And then we've got this positive 2. So the vertical translation is always easier to, it's not as confusing as the horizontal translation because of the fact that, reading it as x negative negative 3, we kind of think of that h as a negative 3. So there's your mapping. You can do inspection if you're confident with it. So all of these can be done by inspection. So eventually, hopefully, you'll be able to look at them, all right, and tell straight away what the transformations are. All right, just going back to the PowerPoint. So when you're doing by inspection, you do need to follow this order, DRT. So that means we do our dilations first. So D for dilations, then R, reflections, and then translations. The reason for that is because if you do it translations first, you can get a little bit confused. Okay, so if you just be consistent with DRT, but it does have to be in a certain format. So I think I've just written the same thing here. So dilations, reflections, and then translations. So if we're doing by inspection, let me just see if there's a question here. That's going to be a good example. All right, I can see one. So question C is a good one to do. All right, and I'll show you in a second why, if we're doing it by inspection. All right, so let's do this one. I'll pause. We'll do this one both by mapping and by inspection. Okay, so I'm just going to rewrite it. So for C, now it doesn't actually matter what the function is, so yeah, you don't need to graph this or anything like that. Just it's the transformations we're dealing with. All right, so if you're doing by inspection, you've got to be careful with what's happening here. Okay, so if I go back to the example of that cubic before, remember, if we're doing it in the same format as, sorry, I'll go back to the parabola. So remember your parabola in turning point form, so we can read the transformations is like that. For this function, oops, let's get rid of that 4. All right, let's put that a up there, and then we can have the x minus h. I don't like using h and k, but I will for this one, just so we can see the similarities. All right, so see how it's quite similar. All right, and that should be a cube there, sorry guys. Very similar, okay? The formatting is very similar, just a different function, okay? So you do the same processes, or read your translations or transformations the same way. I've highlighted this in blue. We need it to look like this to read the transformations. So at this point it doesn't. So I always say, just rewrite it. So instead of having, so we've got y equals 4 over, instead of having 1 minus x, let's just change it to negative x plus 1. All right, just shifted them around. Whoops, that should be a negative. And I'm going to take that negative out. Now, you don't have to, but if we're following the DRT, you do. Okay, so that's why I always say just be consistent, take it out. So we're going to take it out. So I'm just going to take it out of that bracket. That means we're left with x minus 1, and that negative is out the front. So if I took out negative 1 as a common factor, that negative is there. And basically that's still cubed. Because we're cubing, that negative does remain. And the negative, we're going to just put up the top. Oops. Cubed minus 5. Now we can read the transformations. So first of all, we've got this negative 4 up the top. So that's basically our dilations and our reflections. So dilation, factor 4 from the x-axis. So I'm just writing really rushed so I get this video done. All right, so that's our dilation. The negative means it's been reflected along the x-axis. And then last, oh, no, we've got 2 translations. So it doesn't matter what order you do the translations in. It's been translated down 5 and to the right 1. Now, again, you can have transformations, different transformations, and have the same graph, okay? And that can come from not taking that negative out there, all right? But if you take it out, then we can follow the DRT. I don't want to go down that rabbit hole of the difference though. So let's just stick with DRT so we don't get too confused, because sometimes transformations can be quite confusing. Now, before we move on, you might be thinking, well, does it matter if there's a negative there or a negative there? So let's have a look at the graph. All right, so I've just started with our original graph, which was 1 over x cubed. Okay, so there it is. Before we transformed it, okay, so just, before we rearranged things. All right, so there it is, your image. So after the transformations. So we can see it has been reflected. Okay, so you can clearly see it's been reflected. Now, a reflection along the x-axis is, for this graph, not every graph, a reflection in the x-axis is the same as a reflection in the y-axis. It doesn't actually matter. So you could have said for this one, it was reflected along the x-axis or it was reflected along the y-axis. Doesn't matter. But what does matter is the order. So if you always do your dilations, reflections, translations, then it's okay for this one to say that it's either been reflected in the x-axis or the y-axis. So there's our graph, the red one. Now, when I've rearranged it, my final graph, okay, so when we took that negative out and then I put it on the numerator, so you can see there in green, right, it's the same graph, flashing like Christmas, all right, see it? All right, which is the same as this one, which is a bit hard to see, it should be in blue. Oh, can't see it, it's not doing it over the top. There we go. Now, there we go. Like an ambulance. All right, so that negative, if you left it down the bottom, it's the same as if you say, then it would be a reflection in the y-axis. Putting it up the top, reflection in the x-axis. Both are correct. Okay, so that's why I keep emphasizing that for transformations, all right, you can do, things multiple ways. Now, if we do have a look at this, all right, you can see the transformations that have occurred. Now, you could get this way by doing a translation first and then your reflections, okay, but you do need to have the right value. So sometimes it's just easier. Stick to what we know, DRT. All right, let's go back to our document. All right, so if we were doing it actually, I'm just conscious of time. Let's leave it like that because that's a good example. I want to do a mapping one with a bit of a harder question. So let's go to our PowerPoint. All right. Now, the other questions in the PowerPoint can all be done by inspection. Just remember you need to rearrange. So if I have a quick look, I can see which ones need to be rearranged. There was another one. Okay, so just rearrange that one first. Take that negative out first. So when I say negative, take it outside your bracket so we can read it as a reflection, and then it becomes x minus 3. Okay, then that negative for this one, it doesn't matter if it goes on the numerator or stays on the denominator. All right, just the reflection will give you the same graph. All right, here I don't think there were any difficult ones. Oh, actually, this one here. All right, so if we're taking that 2 out, actually, this one I would probably not do by inspection. All right, you have to, it'll become a half, and then you're cubing all of that, and then, oh gosh, this is quite a complicated one, but I want to do some questions. And then that 2 becomes 2 cubed, which is 8. All right, so just be careful with that one. That was a little bit of a tricky one. But yeah, maybe with that one, have a go at doing it with mapping instead, because I think that would be a good practice of them. The rest are pretty straightforward. All right, let's just have a look. So there's a VCAR question. So easy to read these transformations. Just remember, all right, this part here. Change that. You can do this one easily by inspection. This is the sort of question where I would be thinking about it during reading time. So you're thinking, oh, this one's an easy one. You can see that -2, sorry, this -2 here. You've got a reflection and you've got a dilation. The only thing is, because it is multiple choice, sometimes the transformations might be slightly different to your transformations. Just want to do an example. Okay, so here is an example, all right, of a question where we haven't gone from a basic graph. All right, so we've gone from this graph here, y equals the square root of 9 minus x squared, to this graph here. All right, so quite complex. All right, so let's have a look in Word because I need a lot of space for this question. So this is on a tech-free exam. I think it was on the 2022 exam, and it's only worth 2 marks. So basically, you end up with 4 transformations, and you get a half a mark for each, but you don't get half marks in an exam, so they would round it down. So if you got 3 transformations, you're not going to get 1.5 marks, you only get 1. All right, so the tricky part with this one is we've got 9 minus x, and that's really hard to see. Let's make it a bit lighter. You got the 9 minus x squared underneath the square root sign, and you've got 5 minus 4x minus x squared. Now, if you ever get stuck dealing with parabolas or quadratics, remember completing the square often fixes those issues. Okay, so in this case, because we've only got an x squared here, and we've got an x and an x squared here, I know that I need to rearrange this into turning point form by completing the square. Okay, so let's do that first. So I'm only going to deal with what is underneath that square root sign to start off with. So we've got 5 minus 4x minus x squared. All right, so just rearranging that so everything's in order. Now, when you're completing the square, your x squared term has to be positive. So I'm just going to take that negative out. And you'll notice I just used a square bracket. All right, so when we take out the negative, everything, or the sign changes for everything. And then whatever is inside those square brackets, now I'm going to complete the square. So we're going to have x squared plus 4x, then add 4 on 2 squared minus 4 on 2 squared minus 5. Terrible bracket. Start again. All right, so when we're completing the square, it's x plus whatever is inside this bracket here. So x plus 2, all squared. Then we've got minus 4 minus 5, which is minus 9. All right, and then the reason we use square brackets is because that negative applies to our brackets and to this -9. So often students forget that. So we just make sure we use brackets so we don't forget it. All right, so that now is in a much nicer form for us to see our transformation. So I'm going to rewrite each function again. Maybe just make it a little bit smaller. Go up. All right, so we're going from y equals the square root, and I might just rearrange this while we're here. So negative x squared plus 9, and we're going to y equals, and I'm going to put the square root first, just because we're used to seeing that, to the -2, obviously at the front. X plus, oops, don't forget that negative. X plus 2 squared, make it a bit longer, plus 9, and then we've got a plus 3 on the end. Now, just looking at this, all right, so this is where if you're a little bit more confident with transformations, we can say, all right, what is the same on both sides? So we've got this plus 9, so that means it hasn't shifted anywhere there, and this negative and this negative can cancel each other out. So it's a little bit easier to see. So now then we're just left with x squared, which is north, and we've got -2 over x plus 2 squared, whoops, plus 3. Now we can see the transformations by inspection. So much easier. Okay, we've got this reflection here, so it's been reflected in the x-axis. This 2, it's been dilated by a factor of 2 from the x-axis. This 2 means it's shifted to the left 2, and this 3 has gone up 3. All right, so we've taken quite a complicated question and just using completing the square to change our parabola from a expanded form into turning point form, and then we just cancel out any similarities, because remember the graph is moving. So you've got this +9 and this +9. That has made no difference to its transformations. We're only figuring out its transformations. All right, so let's say, hypothetically, you didn't know how to cancel them, but you knew how to complete the square. So basically, we're going from negative x squared, or actually, sorry, negative x plus 9. You can leave the x as x, you don't have to have x dash, to whatever is underneath that square root sign, so x dash plus 2. Rearranging that, hold on, I forgot the 9. I knew I forgot something. X squared plus 2. Sorry, I forgot that negative and the +9. I was looking at the wrong one. All right, so we're just copying what is underneath this square root sign here. Okay, so now we rearrange. So if I take away 9 from both sides, you can see how they go. All right, so take away 9 from both sides. Then divide both sides by a negative. So that means that negative and that negative goes. Come on. And then we're just left with x equals x dash plus 2. And then take away 2 from both sides. All right, and there's your transformation, or one transformation. All right, for your y's, all right, so I'm going to just rewrite the function here, the one in black, not the one above it in blue. Actually, we'll just write x there because it doesn't really matter what's happening with that. We're just looking at everything else. All right, so we're going to subtract 3 from both sides. Sorry, y minus 3. Sorry, that should be y dash. Y minus 3 divided by negative 2 is equal to your new y. All right, rearranging that. So we don't have to do anything with that negative 2 because now we're going to be multiplying. So y dash minus 3 equals negative 2y. Y dash is equal to negative 2y plus 3. And you can read your transformations then from there. All right, so a longer way of doing it, but that's using mapping. You know, if you didn't know to cancel out like we did above. All right, so your transformations, we always do dilations first. So it's been dilated by 2 from the x-axis. Then we do our reflections. So it's been reflected along the x-axis. It has been translated to the left 2 and up 3. Okay, so there's your 4 transformations. So tricky part with this one is completing the square to allow you to do the transformations by inspection, which is what we did here in pink. If you didn't know to cancel, easy to cancel, you could just do mapping like we did down the bottom in blue. All right, I'm going to end there because there's a lot going on. Have a go at doing those questions by inspection and that other VCAR question. All right, bye.